The skies over the Eastern Front witnessed some of the most intense aerial combat in history, where Soviet aircraft and their pilots fought a desperate struggle for air superiority against the Luftwaffe. The story of Soviet aviation during World War II is one of dramatic transformation, from near-catastrophic losses in 1941 to complete dominance by 1945. Soviet aircraft evolved from obsolete biplanes and inadequate early designs into some of the most effective fighting machines of the war. This documentary explores the complete range of Soviet aircraft that took to the skies between 1939 and 1945, examining fighters, bombers, ground attack planes, and specialized aircraft that played crucial roles in defeating Nazi Germany. These were not merely flying machines, but symbols of Soviet industrial resilience, engineering innovation, and the courage of pilots who flew them into battle. From the frozen skies over Moscow to the smoking ruins of Berlin, Soviet aircraft wrote a story of redemption and ultimate victory. The red stars painted on their wings became symbols of hope for occupied peoples and harbingers of doom for the Third Reich. Polycarpov I-15 and I-153 biplane fighters. We begin our journey with aircraft that represented the twilight of the biplane era. The Polycarpov I-15 series consisted of maneuverable biplane fighters that had seen extensive combat in the Spanish Civil War and conflicts with Japan before World War II began. The I-15, with its distinctive gull-shaped upper wing, and its successor, the I-153 Chaika, meaning seagull, were highly agile aircraft powered by radial engines producing around 1,000 horsepower. These biplanes could turn inside virtually any monoplane fighter, making them dangerous in close combat. Armed with four 7.62mm machine guns and capable of carrying small bombs or rockets, they were designed for both air combat and ground attack roles. The I-153 featured retractable landing gear, unusual for a biplane, and could reach speeds of about 440 kilometers per hour. When Germany invaded in June 1941, approximately 3,400 I-15 and I-153 fighters were in Soviet service. However, these biplanes were hopelessly outclassed by modern Messerschmitt fighters. Their slow speed made them easy targets, and their light armament was inadequate against armored aircraft. The fabric and wood construction was vulnerable to even rifle-caliber fire. Despite these limitations, Soviet pilots flew these obsolete fighters with desperate courage during the opening months of the war. Many I-153s were converted to ground attack roles, where their maneuverability and ability to operate from rough fields proved valuable. Some were fitted with rockets for anti-tank work. By late 1942, these biplanes had largely disappeared from frontline service, relegated to training, liaison, and night harassment missions. The I-15 and I-153 represented the pre-war Soviet Air Force, brave pilots flying outdated equipment against a technologically superior enemy. Their sacrifice bought time for newer aircraft to reach the front lines. Polycarpov I-16 fighter. The Polykarpov I-16 was one of the world's first low-wing cantilever monoplane fighters with retractable landing gear, revolutionary when it appeared in 1934. This stubby, rotund fighter earned various nicknames. Soviet pilots called it Ishak, or Little Donkey, while Luftwaffe pilots called it Rada, or Rat. Powered by engines ranging from 700 to 100 horsepower in various versions, the I-16 could reach the speeds of 450 to 525 kilometers per hour, depending on the variant. Armed with 2 or 4 machine guns or 2 20mm cannons in later versions, the I-16 also could carry bombs or rockets for ground attack. The fighter had seen extensive combat in Spain and against Japan, where it proved effective against the aircraft of the mid-1930s. The I-16 was extremely maneuverable due to its short fuselage and lightweight, could sustain significant battle damage, and was relatively simple to maintain. However, by 1941, the I-16 was thoroughly obsolete. It was slower than German fighters, had poor forward visibility due to the large radial engine, featured primitive cockpit layout and instrumentation, and suffered from heavy control forces that exhausted pilots. The open cockpit in early versions and poor rearward visibility made pilots vulnerable. When Operation Barbarossa began, the I-16 was still the most numerous Soviet fighter, with over 1,500 in service. Soviet pilots fought courageously in these outmatched aircraft, sometimes ramming German planes when ammunition ran out. The I-16's obsolescence contributed to catastrophic Soviet losses in the early months of the war. By 1943, remaining I-16s were used for training, night harassment, and ground attack missions where their ability to carry rockets and bombs was still valuable. The I-16 represented Soviet aviation's interwar achievements, but also the dangerous lag in development that left Soviet pilots at a severe disadvantage when war began. Mikoyan Gurevich MiG-1 and MiG-3 fighters. The MiG-1 and its improved version, the MiG-3, represented the first fighters designed by Artem Mikoyan and Mikhail Gurevich, who would become legendary names in aviation history. The MiG-3 appeared in early 1941, powered by a Mikulin AM-35A engine, producing 350 horsepower, giving it excellent high-altitude performance. This sleek fighter could reach speeds of 640 kilometers per hour at high altitude, making it one of the fastest Soviet fighters. Armed with one 12.7mm and two 7.62mm machine guns, with provision for rockets or bombs, the MiG-3 was designed as a high-altitude interceptor. The aircraft featured modern all-metal construction, enclosed cockpit, and retractable landing gear. About 3,300 MiG-3s were produced before manufacturing ceased in 1942. However, the MiG-3 had significant problems that limited its effectiveness. At low altitudes where most Eastern Front combat occurred, the MiG-3's performance was mediocre. The aircraft was difficult to handle, particularly for inexperienced pilots, with tricky landing characteristics. The armament was inadequate, with insufficient hitting power against German aircraft. Forward visibility was poor, and the cockpit layout was criticized by pilots. Most critically, combat on the Eastern Front took place at medium and low altitudes, where the MiG-3's high-altitude optimization was irrelevant. Despite these limitations, some Soviet aces achieved success in the MiG-3, particularly in defending Moscow, where high-altitude interception was sometimes necessary. The fighter also served effectively in reconnaissance roles, where its speed and high-altitude capability were advantages. Production ceased in favor of aircraft better suited to the actual conditions of combat on the Eastern Front. The MiG-3 taught Soviet designers important lessons about matching aircraft design to operational requirements rather than pursuing theoretical performance goals. Lavochkin Gorbunov-Gudkov Lag-3 fighter. The Lag-3 was a fighter constructed primarily of wood, using a special phenolic resin-impregnated plywood called delta wood that was strong, fire-resistant, and required no strategic materials. Designed by Semyon Lavochkin, Vladimir Gorbunov, and Mikhail Gudkov, the Lag-3 entered service in 1941. Powered by a Klimov M105P engine, producing 1,050 horsepower, the aircraft was armed with one 20mm cannon, one or two 12.7mm machine guns, and two 7.62mm machine guns. The Lag-3 featured modern construction, good armor protection for the pilot, self-sealing fuel tanks, and reasonable armament. However, the aircraft quickly gained a terrible reputation among Soviet pilots. It was heavy for its engine power, making it sluggish and slow to climb. The Lag-3 had a maximum speed of only about 560 kilometers per hour, slower than German fighters. Maneuverability was poor, and the aircraft had vicious stall characteristics. Soviet pilots grimly joked that Lag-3 stood for Lackirovany Garantirovanny Grob, or varnished guaranteed coffin. About 6,500 Lag-3s were produced, and pilots had to fly them despite their shortcomings because nothing else was available. The aircraft's saving grace was its robust construction, which could absorb significant battle damage. Some pilots learned to exploit the Lag-3's few strengths. Good diving speed and structural strength allowed aggressive diving attacks. The main value of the Lag-3 was simply that it could be mass-produced using non-strategic materials when Soviet industry was desperate. It kept pilots in the air and factories operating during the darkest period of the war. The Lag-3's poor performance spurred Lavochkin to radically improve the design, leading to the much more successful La-5. Yakovlev Yak-1 fighter. The Yak-1 was the first of a series of fighters designed by Alexander Yakovlev that would become the most numerous Soviet fighters of the war. Entering service in 1940, the Yak-1 was a light, maneuverable fighter optimized for low and medium altitude combat. Powered by a Klimov M105P engine producing 1,050 horsepower, the Yak-1 featured a mixed construction, wood wings and metal tube fuselage with fabric covering, conserving strategic materials. Armed with one 20mm cannon and one or two 12.7mm machine guns, the Yak-1 had adequate firepower. The aircraft could reach speeds of about 580 kilometers per hour and was highly maneuverable, capable of turning with German fighters. The Yak-1 was light and responsive, with good visibility from the cockpit and relatively simple controls that allowed even inexperienced pilots to fly it effectively. However, early Yak-1s suffered from quality control problems due to hasty production and factory evacuations. Engines were unreliable, plywood surfaces sometimes delaminated, and equipment frequently malfunctioned. Despite these problems, the Yak-1 had fundamentally sound design. It was fast enough to engage German fighters, maneuverable enough to dogfight successfully, and armed adequately to destroy enemy aircraft. As production quality improved through 1942 and 1943, the Yak-1 became increasingly effective. Many Soviet aces flew Yak-1s and achieved impressive victory scores. The aircraft served throughout the war in various improved versions. About 8,700 Yak-1s were produced, and the design formed the basis for even better fighters that followed. The Yak-1 represented Soviet fighter design philosophy perfected. Simple, light, maneuverable, adequate performance where it mattered, and capable of mass production. It was designed for the war the Soviets were actually fighting rather than theoretical ideal conditions. Yakovlev Yak-7 fighter. The Yak-7 began as a trainer variant of the Yak-1, but evolved into an effective fighter. The two-seat trainer version retained combat capability, and single-seat fighter variants soon appeared. The Yak-7 was slightly heavier than the Yak-1, but more robust, with better build quality. Various versions appeared with different armament configurations and engine improvements. The Yak-7B variant, which appeared in 1942, became the most numerous, with about 6,400 produced. This version featured improved armor protection, better armament with one 20mm cannon and two 12.7mm machine guns, and refined aerodynamics. Performance was similar to the Yak-1 with speeds around 570 kilometers per hour, but the Yak-7 was considered more forgiving and easier to fly. The stronger structure allowed more aggressive maneuvering. Many pilots preferred the Yak-7 for its reliability and solid feel. The aircraft served extensively from 1942 through 1944, participating in all major battles including Stalingrad, Kursk, and the liberation campaigns. Several Soviet aces achieved high scores flying Yak-7s. The aircraft's success led directly to the development of the Yak-9, which refined the design further. The Yak-7 demonstrated how a training aircraft could be successfully converted to combat use and showed the value of incremental improvements rather than radical redesigns. Yakovlev Yak-9 fighter. The Yak-9 was the most produced Soviet fighter of World War II, with approximately 16,700 built in numerous variants. Appearing in 1942 as an evolution of the Yak-7, the Yak-9 featured metal spars in the wings instead of wood, increasing strength and allowing greater fuel capacity. The basic Yak-9 had similar performance to earlier Yakovlev fighters, but greater range and versatility. What made the Yak-9 exceptional was the variety of specialized variants developed. The Yak-9D long-range fighter had extended range for bomber escort. The Yak-9T mounted a powerful 37mm cannon for anti-tank and anti-bomber work, capable of destroying German tanks and heavy bombers with single shots. The Yak-9K carried a massive 45mm cannon, the heaviest gun ever fitted to a single-engine fighter, though the recoil was tremendous. The Yak-9B was a light bomber carrying up to 400 kilograms of bombs. The Yak-9U, appearing in late 1943, featured a more powerful engine and reached speeds of 700 kilometers per hour, making it one of the fastest fighters of the war and capable of meeting German late-war fighters on equal terms. All Yak-9 variants retained the basic characteristics that made Yakovlev fighters successful: lightweight, excellent maneuverability, simple maintenance, and good low-altitude performance. The Yak-9 served on all fronts from 1942 through war's end and remained in Soviet service afterward. Many Allied nations received Yak-9s after the war. The aircraft saw extensive combat in the hands of Soviet aces and proved highly effective against all German aircraft types. The Yak-9's versatility and ease of production made it indispensable to Soviet air operations. It could perform fighter, ground attack, reconnaissance, and light bombing missions depending on the variant. The Yak-9 epitomized Soviet pragmatic design philosophy. Create a fundamentally sound basic design, then modify it to fill whatever roles are needed, maintaining high production while maximizing versatility. Yakovlev Yak-3 fighter. The Yak-3 was the lightest and most agile Soviet fighter of World War II, representing the culmination of Yakovlev's design philosophy, emphasizing maneuverability and low-altitude performance. Appearing in 1944, the Yak-3 was actually a simplified, refined version of earlier designs, stripped of excess weight and optimized for dogfighting. Weighing only 2,750 kilograms fully loaded and powered by a 1,300 horsepower engine, the Yak-3 had an exceptional power-to-weight ratio. The fighter could reach 655 kilometers per hour and climb rapidly. Most impressively, the Yak-3 could outturn virtually any opponent. German pilots learned to avoid dogfighting with Yak-3s at low altitude, where the Soviet fighter was nearly unbeatable. Armed with one 20mm cannon and two 12.7mm machine guns, the Yak-3 had adequate firepower. The aircraft was simple to fly, forgiving of pilot errors, and required minimal maintenance. About 4,800 Yak-3s were produced, and the fighter quickly became a favorite of Soviet pilots. The French Normandy Niemen Squadron, fighting on the Eastern Front, specifically requested Yak-3s and achieved remarkable success with them. German intelligence warned Luftwaffe pilots to avoid combat with Yak-3s below 5,000 meters altitude. The Yak-3 demonstrated that by 1944, Soviet fighter design had not only caught up with German aviation, but in some aspects surpassed it. The aircraft represented a complete reversal from 1941, when Soviet fighters were universally inferior. The Yak-3's success validated the Soviet approach of optimizing designs for actual combat conditions on the Eastern Front, rather than pursuing abstract performance goals. Lavochkin La-5 fighter. The La-5 represented a dramatic redemption for designer Semyon Lavochkin after the disappointing LAGG-3. In 1942, Lavochkin re-engineered the LAGG-3 airframe to accept a powerful Shvetsov AS-82 radial engine, producing 1,700 horsepower. The transformation was dramatic. Where the LAGG-3 was sluggish and underpowered, the La-5 was fast and energetic. The new fighter could reach 648 kilometers per hour and climb rapidly. The radial engine was reliable, easier to maintain, and more resistant to battle damage than inline engines. The La-5 initially retained the LAGG-3's armament of two 20mm cannons, providing good firepower. The aircraft was simple to build and maintain, and its performance finally gave Soviet pilots a fighter competitive with German aircraft. The La-5 entered service in mid-1942 and quickly proved its worth. At the Battle of Stalingrad, La-5s helped Soviet forces achieve air superiority. The fighter was continuously improved. The La-5F featured a fuel-injected engine and improved aerodynamics, while the La-5FN had further refinements and reached 648 kilometers per hour. About 10,000 La-5s were produced in various versions. Many Soviet aces flew La-5s and achieved impressive scores. The fighter was particularly effective at low and medium altitudes where most combat occurred. The rugged radial engine could sustain significant damage and continue operating, bringing pilots home who would have been lost in liquid-cooled aircraft. The La-5 represented what Soviet industry could achieve when given good designs: mass production of effective weapons that matched operational requirements. The fighter's success validated Lavochkin's design philosophy and led to even better aircraft. Lavochkin La-7 fighter. The La-7 was the ultimate evolution of Lavochkin's radial engine fighters and one of the finest fighters of World War II. Appearing in late 1944, the La-7 featured a refined airframe with reduced drag, improved aerodynamics, and structural refinements that reduced weight. Powered by the same AS-82FN engine as the late La-5FN, the La-7 achieved superior performance through better design. The fighter could reach 680 kilometers per hour, climbed excellently, and was highly maneuverable. Armed with three 20mm cannons in most versions, the La-7 had devastating firepower. The aircraft was considered by many pilots to be the best Soviet fighter of the war. Only about 5,900 were produced before war's end, but they had significant impact. The La-7 equipped elite guards regiments and units of top Soviet aces. Even Kozhedub, the highest-scoring Allied ace of the war, with 62 victories, flew the La-7 for many of his kills. The fighter was effective against all German aircraft, including jets on occasion. The La-7 could dogfight with any opponent and had the speed to catch most enemy aircraft. Its 3 cannons could destroy bombers quickly and fighters with single bursts. The aircraft was reliable and forgiving, allowing pilots to focus on combat rather than managing a difficult aircraft. The La-7 represented Soviet fighter design matured through years of combat. It incorporated all the lessons learned since 1941: powerful engine, simple construction, excellent low-altitude performance, good armament, and reliability. By 1945, Soviet fighters like the La-7 dominated the skies over Germany, a complete reversal from the desperate struggles of 1941. Bell P-39 Airacobra and P-63 King Cobra. Although American-designed, the Bell P-39 Airacobra and P-63 King Cobra deserve mention as they were extensively used by Soviet forces under Lend-Lease. The Soviets received about 4,700 P-39s and 2,400 P-63s, making them significant components of Soviet fighter strength. These aircraft featured unusual mid-engine layout, with the engine behind the pilot and powerful nose-mounted armament, including 37mm cannons. The P-39 and P-63 were not particularly successful with American forces, but proved effective in Soviet hands. Soviet pilots appreciated the heavy firepower, good low-altitude performance, radio equipment superior to Soviet aircraft, comfortable cockpits with good heating, and sturdy construction. The 37mm cannon was devastating against ground targets and aircraft alike. Many Soviet aces flew P-39s, including Alexander Pokrishkin, the second highest-scoring Soviet ace with 59 victories. Soviet pilots developed tactics that exploited the aircraft's strengths while avoiding their weaknesses. The P-39 and P-63 supplemented Soviet fighter production at critical times and provided capabilities that indigenous designs sometimes lacked. They demonstrated that Soviet pilots could succeed in any aircraft given proper tactics and training. The Airacobra became one of the most numerous fighters in Soviet service during 1943-1944. Petryakov Pe-2 dive bomber. Moving to bombers, we begin with the Petryakov Pe-2, the most important Soviet bomber of the war. This twin-engine dive bomber, designed by Vladimir Petryakov, entered service in 1940 and represented a quantum leap in Soviet bomber capability. The Pe-2 was fast for a bomber, capable of 540 kilometers per hour, heavily armed with multiple machine guns, and could carry 200 kilograms of bombs. The aircraft could perform level bombing, dive bombing, and photo reconnaissance missions. Powered by 2 Klimov M105 engines, the Pe-2 had good performance at all altitudes and was maneuverable enough to evade many fighter attacks. The crew of 3 operated in cramped but efficient conditions. The Pe-2 featured modern systems, including retractable landing gear, variable pitch propellers, and dive brakes for accurate bombing. About 11,400 Pe-2s were produced in numerous variants, making it one of the most numerous twin-engine aircraft of the war. The Pe-2 served throughout the conflict on all fronts, performing tactical bombing, reconnaissance, night harassment, and even fighter duties with special variants. The aircraft's speed and agility gave it reasonable survivability, though losses were significant in daylight operations against heavy defenses. Pe-2 units played crucial roles in major battles including Moscow, Stalingrad, Kursk, and all offensive operations through war's end. The bomber could strike German positions accurately, support ground forces effectively, and gather vital intelligence through photo reconnaissance. Many variants appeared with different armament, engines, and equipment. The Pe-2 represented Soviet tactical aviation at its best: fast, versatile, producible in quantity, and effective in the roles required on the Eastern Front. It demonstrated that Soviet design bureaus could create sophisticated combat aircraft, matching Western standards. Tupolev Tu-2 bomber. The Tupolev Tu-2 was arguably the best Soviet bomber of World War II, though it appeared relatively late and was produced in smaller numbers than the Pe-2. Designed by Andrei Tupolev while he was imprisoned, the Tu-2 first flew in 1941 but didn't enter service until 1944 due to production difficulties and focus on other aircraft. The Tu-2 was a twin-engine bomber powered by two Shvetsov Ash-82 radial engines, producing 850 horsepower each. The bomber could reach 547 kilometers per hour, carry up to 3,000 kilograms of bombs, and was heavily armed with two 20mm cannons and three machine guns. The crew of four operated in relatively comfortable conditions with good visibility. The Tu-2 featured modern systems, robust construction, and excellent handling characteristics. Pilots praised the aircraft for being easy to fly, forgiving, and capable. The bomber could absorb significant battle damage and return home. Only about 2,100 Tu-2s were produced during the war, but they had disproportionate impact. Tu-2 units achieved excellent results with lower loss rates than other bombers. The aircraft served in tactical bombing roles, attacking German positions, transportation, and concentrations. The Tu-2's combination of speed, bomb load, defensive armament, and survivability made it highly effective. The bomber remained in Soviet service long after the war and was exported to several nations. The Tu-2 demonstrated that by war's end, Soviet aviation could produce aircraft equal or superior to foreign designs. It represented the maturation of Soviet bomber design and the accumulated experience of years of combat. Ilyushin Il-4 Sturmovik ground attack aircraft. The Ilyushin Il-4 Sturmovik was the most produced military aircraft in history, with approximately 36,000 built, and arguably the most important Soviet aircraft of World War II. This single-engine ground attack aircraft, designed by Sergei Ilyushin, revolutionized close air support. The Il-2's key innovation was its armored shell. The forward fuselage, including the cockpit, engine, cooling system, and fuel tanks, was an integral load-bearing armored structure rather than added plates. This armored tub weighed about 700 kilograms, but was essential structure rather than deadweight. The armor protected against ground fire up to 20 mm, allowing the Il-2 to attack at low altitude with relative survivability. Powered by a Mikulin AM-38 engine producing 1,600 horsepower, the Il-2 carried devastating armament: two 23mm or 37mm cannons, two machine guns, up to 600 kilograms of bombs, and 8 rockets. The aircraft could destroy tanks, vehicles, artillery, bunkers, and troops with equal effectiveness. Early Il-2s were single-seaters, but combat experience showed the desperate need for rear defense. From 1942, a rear gunner position was added despite protests from designers about weight and performance penalties. The two-seat Il-2 became standard. The Sturmovik operated at low altitude, attacking German positions in devastating waves. German soldiers feared these aircraft more than any other Soviet weapon, calling them Black Death and Meat Grinder. The Il-2's typical attack profile involved approaching at low altitude, firing rockets and cannons, then bombing while climbing away as the rear gunner engaged pursuing fighters. The aircraft absorbed tremendous punishment and often returned with hundreds of bullet holes. However, Il-2 losses were high, with over 11,000 lost in combat. The rear gunner position was particularly dangerous. Despite losses, the Il-2's impact on ground combat was immense. Sturmovik attacks shattered German armor concentrations, destroyed supply columns, and devastated troop positions. At the Battle of Kursk, Il-2s played a crucial role in blunting German armored thrusts. The aircraft served throughout the war on all fronts, and Stalin personally emphasized its importance. The Il-2 represented Soviet military aviation philosophy: create weapons optimized for actual tactical needs, accept casualties if the weapon is effective, and produce in overwhelming numbers. No other aircraft better embodied the attritional nature of the Eastern Front or contributed more directly to ground combat success. Ilyushin Il-4 long-range bomber. The Ilyushin Il-4 was the principal Soviet long-range bomber of the war, serving in both maritime and strategic bombing roles. Originally designated DB-3F, this twin-engine bomber entered service in 1940 as an improved version of the earlier DB-3. Powered by two M88 engines producing 100 horsepower each, the Il-4 could carry 1,000 kilograms of bombs or torpedoes over long distances. The bomber had a range of over 3,500 kilometers, allowing it to strike deep into enemy territory. Armed with 3 machine gun positions for defense, the crew of 4 operated in cramped, cold conditions on long missions. About 5,300 Il-4s were produced during the war. These bombers performed various missions: strategic bombing of German industry, cities and oil facilities, naval aviation torpedo bombing against German shipping, long-range reconnaissance, supply missions to partisans, and even the famous raid on Berlin in August 1941 that shocked the German leadership. The Il-4 was not a particularly advanced aircraft with modest performance and limited defensive armament. However, it was reliable, relatively simple to build and maintain, and could perform the missions required. Il-4 crews faced tremendous dangers on long missions over enemy territory, with limited navigation equipment and vulnerable to fighters and anti-aircraft fire. Loss rates were high, particularly in daylight operations. By 1943, most Il-4 operations were conducted at night to reduce losses. The bomber remained in service throughout the war, though increasingly supplemented by other types. The Il-4 demonstrated Soviet capability to conduct strategic bombing operations despite limited resources and showed the determination of crews flying long, dangerous missions in modest aircraft. Petryakov Pe-8 heavy bomber. The Petryakov Pe-8 was the only Soviet four-engine heavy bomber produced during the war, though in very limited numbers. Only about 90 were built due to complex construction, resource demands, and Soviet focus on tactical rather than strategic aviation. The Pe-8 was nevertheless an impressive aircraft. Powered by four AN-35A engines producing 1,350 horsepower each, the bomber could carry up to 4,000 kilograms of bombs over long distances. The Pe-8 had a range of over 5,000 kilometers and could reach altitudes above 9,000 meters. Armed with two 20mm cannons and two machine guns in various positions, with a crew of 11, the Pe-8 was a serious strategic weapon. These bombers conducted notable missions including raids on Berlin, attacks on German industry in Königsberg and Danzig, long-range reconnaissance flights, and a famous diplomatic mission carrying Soviet Foreign Minister Molotov to Britain and the United States in 1942. The Pe-8 demonstrated that Soviet designers could create heavy bombers matching Western standards. However, Soviet military doctrine emphasized tactical aviation, supporting ground forces rather than strategic bombing campaigns. Resources were better spent on fighters and ground attack aircraft that directly influenced frontline combat. The few Pe-8s that served performed admirably, and several survived the war. The Pe-8 represented Soviet heavy bomber capability, but also the pragmatic decision to focus resources where they would have greatest impact on the actual war being fought. Polikarpov Po-2 utility biplane. The Polikarpov Po-2 was a humble biplane trainer and utility aircraft that became one of the most important Soviet aircraft of the war, though in unconventional roles. Originally designated U-2, this simple biplane first flew in 1927 and was produced in vast numbers for pilot training. Powered by a small radial engine producing only 100 horsepower, the Po-2 was slow, with maximum speed of about 150 kilometers per hour, and carried minimal equipment. When war came, Po-2s were pressed into service for night harassment bombing, a role for which they proved surprisingly effective. Flying at night at very low altitude, Po-2s dropped small bombs on German positions, supply dumps, and troop concentrations. The aircraft were nearly impossible to intercept due to their slow speed. Fighters stalled trying to fly slowly enough to engage them, and the wooden construction made them poor radar targets. The famous Night Witches, the all-female 588th Night Bomber Regiment, flew Po-2s throughout the war, conducting tens of thousands of sorties and earning numerous decorations. German troops hated these night raiders that denied them sleep and caused constant harassment. Beyond night bombing, Po-2s served in liaison, medical evacuation, supply missions to partisans, and reconnaissance. The aircraft could operate from any field or clearing and required minimal maintenance. Over 40,000 Po-2s were produced, making it one of the most numerous aircraft ever built. The Po-2 demonstrated that even obsolete aircraft could be effective when used in appropriate roles. It showed Soviet adaptability and willingness to employ any weapon that could contribute to victory. The humble biplane became a symbol of Soviet determination and ingenuity. The aircraft of the Soviet Union during World War II tell a dramatic story of transformation from near annihilation to complete air superiority. In June 1941, the Soviet Air Force was devastated by surprise German attacks that destroyed thousands of aircraft on the ground and in unequal air combat. Obsolete biplanes and inadequate designs faced the experienced, well-equipped Luftwaffe with predictable results. By 1945, the situation had completely reversed. Modern Soviet fighters dominated the skies. Ground attack aircraft devastated German positions with impunity, and bombers struck deep into Reich territory. This transformation resulted from multiple factors. New designs like the Yak-3, La-7, and Tu-2 that matched or exceeded German aircraft. Massive production increases that overwhelmed German forces through sheer numbers. Improved pilot training that created skilled aviators and deadly aces. Tactical innovations that exploited Soviet aircraft strengths while minimizing weaknesses, and industrial evacuation and expansion that created the world's largest aviation industry. Soviet aircraft production reached staggering totals. Approximately 158,000 aircraft produced during the war years, dwarfing German production and even exceeding American output in some categories. The Soviet Union produced more Il-2 Sturmoviks alone than Germany produced fighters during the entire war. This industrial achievement was as important as any technical innovation. Soviet aviation demonstrated certain consistent philosophies: emphasis on low-altitude performance where actual combat occurred, prioritization of simplicity for ease of production and maintenance, acceptance of rough finish and primitive features if fundamental performance was adequate, focus on tactical aviation supporting ground forces rather than strategic bombing, willingness to produce multiple designs simultaneously and accept redundancy, and rapid incorporation of combat experience into improved variants. Soviet aircraft were rarely elegant or sophisticated by Western standards, featuring crude internal finish, basic equipment, and sometimes primitive systems, but they were designed for the war the Soviets were fighting, a brutal attritional struggle where quantity, reliability, and adequate performance mattered more than individual sophistication. The legacy of Soviet World War II aviation extended far beyond 1945. Design bureaus like Mikoyan Gurevich, Yakovlev, Lavochkin, Sukhoi, Ilyushin, and Tupolev continued creating aircraft throughout the Cold War and beyond. The Yak-3 and La-7 influenced post-war fighter development. The Il-2 concept evolved into dedicated close air support aircraft. Soviet aviation doctrine emphasizing tactical aviation and massive numbers shaped air forces worldwide. Many Soviet World War II aircraft served for decades after the war, exported to dozens of nations, and seeing combat in Korea, the Middle East, Africa, and elsewhere. Perhaps most significantly, Soviet aviation during World War II demonstrated that industrial capacity, when properly organized and directed toward pragmatic goals, could overcome initial technological disadvantages and achieve complete air superiority. The transformation from the catastrophic losses of 1941 to the dominant Air Force of 1945 showed that persistence, adaptation, and overwhelming production could defeat even a highly skilled enemy. The red stars on Soviet aircraft began the war as symbols of desperation, but ended as harbingers of victory. The wings of the Red Star carried Soviet forces from the gates of Moscow to the ruins of Berlin, playing an indispensable role in defeating Nazi Germany. These aircraft, and the pilots, designers, and factory workers who created and flew them, changed the course of history and demonstrated the industrial and human capacity of a nation fighting for its very existence. Their story remains a testament to what can be achieved when technical skill, industrial might, tactical innovation, and human courage combine in pursuit of victory against overwhelming odds. The skies over the Eastern Front witnessed transformation from defeat to triumph, written in the contrails of Soviet aircraft that ultimately ruled the air over a defeated Third Reich.